This video is an introduction to the trig functions sine, cosine, and tangent. This is AP Precalculus topic 3.2. If you appreciate this content, please give it a like. Here are two vocabulary words that come up all the time in trigonometry. Definition number 1, standard position. In the coordinate plane, an angle is in the standard position when its vertex is at the origin and one ray of the angle lies on the positive x-axis. For example, this blue angle is in standard position because the vertex is at the origin and one ray of the angle is on the positive x-axis. Definition 2, terminal ray. The terminal ray is the second ray of an angle in standard position. For example, this red ray is the terminal ray of this angle. Now we can define the trig functions sine, cosine, and tangent. Given an angle in standard position and a circle centered at the origin, there is a point P where the terminal ray intersects the circle. If we call this angle in standard position theta, we can define the sine of theta as the ratio of the vertical displacement of P from the x-axis to the distance between the origin and point P. In other words, the sine of theta is equal to y over r. The cosine of theta is the ratio of the horizontal displacement of P from the y-axis to the distance from the origin to the point P. In other words, cosine theta is equal to x over r. The tangent of theta is the slope of the terminal ray. That's the rise over run that you learned back in Algebra 1. So the tangent of theta is the ratio of the vertical displacement to the horizontal displacement of P. In other words, the tangent of theta is equal to y over x, or the tangent of theta is equal to sine theta over cosine theta. These three trig functions are fundamental to the rest of this course, so pause the screen, write down these definitions, and memorize them. Example 1. The figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of point P are x, y. Which of the following is true about the cosine of theta? Before I read any of the options, let's remember the definition of cosine. The cosine of theta is x over r. That's the horizontal displacement divided by the distance from the origin. The question is, do we know any of these variables? Well, we do, because they gave us the coordinates of this point right here, 3, 0. That tells us that the radius of this circle is 3. That means if we were to move this to this position, this is still the radius of the circle. So this distance is 3. That is the value of r. Therefore, the cosine of theta is equal to x over 3. So the answer is A. The cosine of theta is equal to x over 3 because it is the ratio of the horizontal displacement of P from the y-axis to the distance between the origin and P. Example 2. The figure shows a circle with radius 5 centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. Find the following values. Part A, sine of theta. We know that the sine of theta is y over r. So in this case, we know that the radius is 5. So it's going to be something divided by 5. But they did not give us the coordinates of point P. We need to figure that out for ourselves. Point P is lined up with this point 3, 4. So it will have the same x coordinate, but it will have the opposite y value. So this point has a y value of 4, so point P will have a y value of negative 4. And that's what we need right now. Y over r becomes negative 4 over 5. What about the cosine of theta? We know that cosine theta is defined as x over r. Well, x is 3 and r is 5. So that's cosine. Now time for tangent. Tangent theta is defined as y over x. So that will be negative 4 divided by 3. By the way, a fraction has the same value whether the negative sign is in the numerator, the denominator, or right here in the middle. So negative 4 over 5 is equal to negative 4/5, and negative 4 over 3 can be written as negative 4/3. The figure shows a circle with radius r centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of P are x, y. The points Q, R, and S are the result of reflecting point P across the y-axis, the origin, and the x-axis, respectively. Example 3. Find the coordinates of the points Q, R, and S in terms of x and y. Let's start with the point Q. If the vertical displacement of point P is y, then the vertical displacement of Q is also y. These are at the same height. If the horizontal displacement of point P is x, then the horizontal displacement of Q will be the opposite of x. It is the same distance from the y-axis, but in the opposite direction. Now let's jump down to point S. If the horizontal displacement of point P is x, then the horizontal displacement of point S will also be x. They are the same distance from the y-axis. If the vertical displacement of point P is y, the vertical displacement of point S will be the opposite of y. They are the same distance from the x-axis, but in opposite directions. Point Q and point R have the same horizontal displacement. So we already figured out that point Q has a horizontal displacement of negative x, so that will be the same for point R. Point R will have the same vertical displacement as point S, and that is negative y. So the vertical displacement of point R is negative y. So these are the answers for example 3. Example 4. Find the sine of the angle whose terminal ray intersects the circle at point S. We know that the definition of sine theta is y over r. So we need the vertical displacement divided by the radius. But the vertical displacement of point S is the opposite of y. So that's the answer to example 4. Example 5. Find the cosine of the angle whose terminal ray intersects the circle at point Q. Our memorized formula for cosine theta is x over r. But right now, let's think of this as the horizontal displacement divided by the radius. At point Q, the horizontal displacement is negative x. So cosine theta will equal negative x over r. You may also write the answers to examples 4 and 5 as negative y over r and negative x over r. Example 6. Find the tangent of the angle whose terminal ray intersects the circle at point R. The memorized formula for tangent theta is y over x, but to avoid confusion, just think of this as the vertical displacement divided by the horizontal displacement. At point R, the vertical displacement is negative y, and the horizontal displacement is negative x. So tangent theta is equal to negative y divided by negative x. But definitely do not leave it like this. A negative divided by a negative is a positive, so let's write it as simply y over x. Example 7. Let theta be an angle in standard position whose terminal side coincides with the line y equals negative 3x in quadrant 2. Find the following values. Here's a picture of angle theta in standard position with the terminal ray in the second quadrant. If the coordinates of the point where the terminal ray intersects the circle are x, y, then we can draw a right triangle in the second quadrant where this vertical side of the right triangle is y and the horizontal side is x. The hypotenuse is the radius of the circle, so let's call that r. The Pythagorean theorem gives x squared plus y squared is equal to r squared. However, we know that y is equal to negative 3x. So let's make that substitution. Then we have x squared plus negative 3x squared is equal to r squared. If you square negative 3x, you get 9x squared. So this is going to be equivalent to x squared plus 9x squared is equal to r squared. But these are like terms. 1x squared plus 9x squared is 10x squared. So 10x squared is equal to r squared. Let's solve this for x by dividing both sides by 10. That will give us x squared is equal to r squared over 10. We can solve for x by taking the square root of both sides. And normally we would say x is equal to plus or minus the square root of r squared over 10. However, the terminal ray is in the second quadrant, so we know that the horizontal displacement will specifically be negative. We can simplify this a little bit because when you take the square root of a fraction, you take the square root of the numerator and the denominator separately. So this will simplify down to the opposite of r over the square root of 10. The square root of r squared is r. The key to finding the values of sine, cosine, and tangent is that x is equal to negative r over the square root of 10. Sine theta is equal to y over r. So that means that sine theta is equal to negative 3x over r. So this will become negative 3x over r. But we just found that x is negative r over the square root of 10. So sine theta becomes negative 3 times negative r over the square root of 10, all divided by r. A negative times a negative is a positive. So we end up with sine theta equals 3r over the square root of 10, all divided by r. Quick side lesson, a over b, all divided by c, is a over bc. I don't want you to have to think through the extra step of multiplying by the reciprocal like this. Oh, when you divide by a fraction, you multiply by the reciprocal, you see. So this will be a over b times 1 over c, and then that gives us a over bc. I want you to automatically go, whenever you divide a fraction by an extra thing, you just multiply that thing into the denominator. So a over bc immediately. So dividing this fraction by r is just going to put this r in the denominator. Sine theta is equal to 3r over r radical 10. Now we can see that these r's will cancel each other out. So we are left with the final answer of sine theta is equal to 3 over radical 10. Kabam! Let's do something similar with the cosine of theta, which is defined as x over r. So since x is negative r over radical 10, that gives us the cosine of theta is equal to negative r over the square root of 10, all divided by r. We know that when you divide a fraction by something else, the thing you're dividing by ends up in the denominator. So we get cosine theta is equal to negative r over r radical 10. These r's will cancel each other out. That leaves us with the cosine of theta is equal to negative 1 over radical 10. Cosine was quite a bit easier than sine in this case. Tangent is easier still. If you remember that tangent is the slope of the terminal ray, and the terminal ray coincides with the line y equals negative 3x. The slope is right there, the negative 3. So if you remember all that, you can figure out that the tangent is negative 3 without actually doing any work. But if you did not remember that, then here's a little bit of work you would have to do. Tangent is defined as y over x, but y is equal to negative 3x in this case. So that means that tangent theta will equal negative 3x over x. But oh look, the x's cancel each other out. So we end up with tangent theta is equal to negative 3. And that's it for example 7. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.